Welcome back. Let's do question 10.2. In the diagram, PQRS is a cyclic quad. KP is a tangent to the circle. At P, C and D are points on chords PQ and PS respectively, and CD meets RS produced at A, and then CA is parallel to QS, RC is drawn, angle P1 is called angle R2. We discussed the information and the writer in the previous question when we were doing 10.1. Let's just remember what we got. We proved that angle S1 is equal to angle T2. We proved that this angle is equal to this angle. And then the other thing, we named our angle P1X. So we say this one is X. And then Q1 is going to be X also because of the tan chord theorem. KP is the tangent meeting the chord PS at P, then PS subtends Q1 at the circumference. So this angle is X, and we're also given that angle P1 is equal to angle R2, meaning that angle R2 is also X. Right, let's do this 10.2. We want to prove that AD over AR is equal to AS over AC. What we can do here is to identify the triangles. So when identifying the triangles, this is what you can do. You move across these two ratios. You move across like this and then try to identify triangles. Or sometimes you can move like this, left hand side and the right hand side. Let's start by checking across. So we move like this. We look at ADAS. Do we have a triangle which is ADS? So the A must appear once because we have two of them here. So we look at triangle ADS. ADS. Let's highlight the triangle. This is triangle ADS. Then we look at the denominators. Do we have triangle ARC? ARC. A appears twice, so we take it once here. This is how you can identify your triangles. So now we have to prove that these two triangles are similar. So we have in triangle ADS and triangle ARC. Right, let's start with angle A, which is a very easy one. So angle A in triangle ADS is equal to angle A in triangle ARC because this is a common angle. So angle A is equal to angle A since this is a common angle. And then which other angle can we prove here? We need to check what we just proved. Let's check what we just proved. We proved that angle T2 is equal to angle S1. So this angle S1 should be equal to which angle in our yellow triangle here? If you check, this angle T2 and angle C2 are equal. And then why are they equal? Because these are alternate angles. Angle T2 is equal to angle C2. These are alternate angles. CA is parallel to QS. We already proved that angle S1 is called angle T2. So angle T2 is equal to angle S1. We already proved that. Proven. And then from here, we can easily see that angle C2 is equal to angle S1. Okay. Angle C2 is equal to angle T2. Angle S1 is equal to angle T2. Therefore, angle S1 is equal to angle C2. So now we have two pairs of corresponding angles being equal. We're left with the third pair, which is angle D1 and angle R1. Once we prove that the corresponding two pairs are equal, then automatically the third pair becomes also equal. So we can say therefore angle D1 is equal to angle R2. Okay, you can say third angle of triangle, or you can say sum of angles in a triangle. But this is just enough to prove that this pair and this pair are equal. Just enough to prove that the two triangles are similar. And then now, what can you say from here? So you can say triangle ADS is similar to triangle. Angle A goes with angle A. And then angle D goes with angle R. And then angle S goes with angle C. So now we can say triangle ADS is similar to triangle ARS because of angle, angle. Right, and then from this we can conclude and say therefore AD over AR is equal to DS over RC, and then is equal to AS over AC is equal to AS over AC. And I want to prove that AD over AR, so we have this AD over AR is equal to AS over AC, AS over AC. Therefore, AD over AR is equal to AS over AC. Done.